Applications of integration, lesson 4, volumes of revolution. Concept we're going to look at are volumes of regions not bound by an axis, and the rotations about the x and y axis again. So in this example, we're going to look at a volume of revolution where the regions are not bounded by the x-axis. So look at two curves here, y equals x and y equals x squared. As you can see, we have two intersection points. Here at 1, 1 and at the origin 0, 0. If the shaded region is rotated about the x-axis, the volume V is given by the following formula. It's the same application as lesson 3. Here we're working out the definite integral of the integrand, which is fx squared subtract gx squared in reference to dx. Example 11. Determine the volume of the solid formed by revolving the region bounded by the graphs of y equals root x and y equals x squared about the x-axis. Here, I've actually graphed that, and this is actually the solid formed. So here we can see our y equals x squared, and here is our y equals root x. If we rotate that, or revolve that around the x-axis, that's actually the solid we get. So a solution, let fx be root x, which is the outer radius, and gx, which is the inner radius. Now, integrating takes place between 0 and 1. So here, we're going to apply our formula for the volume of revolution, which is fx squared take gx squared, and multiply that by the constant pi. Applying that formula, fx is root x, gx, as I said, was x squared. Subbing those into our formula, we now can integrate. First, we need to simplify these fx squared and gx squared. So fx squared becomes just simply x, gx squared becomes x squared to the power of 2, which is x to the 4. We now have a very simple integrand. Applying the power rule, we have x to the 2 over 2, x to the 5 over 5, and our limits, our upper and lower limit, are 0 and 1. Subbing those values in and evaluating that definite integral, the volume is 3 pi on 10 cubic units. Now we're going to look at rotation of two curves about the y-axis. If the region shaded is rotated about the y-axis, the volume V is given by. Instead, we have a rule that is very similar to our lesson 3. We have functions of y. Our function of y, which is fy, is squared. Subtract our function of y in terms of g is squared, and that becomes our integrand. We integrate or anti-differentiate with respect to y. Make sure we multiply by pi at the end. Example 12. Determine the volume in the area between the curves fx, which is a quadratic, and gx is another quadratic, is rotated about the y-axis. So here, this is our quadratic, which has a reflection about the x-axis. So here is our 12 take x squared. Here is our 2x squared. There's our intersection point. Determine the points of intersection. If I let fx and gx equal each other, that's called a simultaneous equation. I'm now going to solve for x. I'm now going to rearrange by adding x squared to both sides, divide both sides by 3, and take the square root of our 4. That's plus or minus the square root of 4, which is plus or minus 2. Now we're going to examine the 2 here because our negatives will be the opposite side anyway. So we'll ignore the negative, just take it as between 0 and 2. Step 3 is to now rewrite fx and gx. That is, make x the subject, so then we have a function in terms of y. So the first step for fx is to replace fx with y. We're going to isolate x now, make x the subject. Now to do so, I could actually rearrange this by adding x squared to both sides, then taking y. Now because the x squared is going to be over here now, the inverse operation is to take the square root of both sides. So x is the square root of 12 take y. This one's a bit easier. Y equals 2x squared. We can divide both sides by 2, then take the square root of both sides and we now have x in terms of y. Now recall and apply the formula for the volume. Note, Fy is the outer. So in this case, our formula, which is Fy squared take Gy squared, can be applied by subbing these two in. We can sub this one in, we can sub this one in. Substituting those in, our Fy, which is the square root of 12 take y, is here. If we actually square that, we're going to then only have 12 take y. Similarly, if we have gy all squared, and we've got the square root of y over 2, and we square it, we're going to end up with y over 2. Next, we're going to simplify this integrand by collecting like terms. So that means we'll have 12 take 1.5 y. We've got a negative y, take another half y on. We can then simply integrate using the power rule. So 12 will become 12y, 3y over 2 becomes 3y squared. We need to divide by 2, which is why that 2 becomes a 4. We can then sub in our 0 and 8, multiply it by pi, and we get 48 pi cubic units. That's lesson 4 in terms of a bit of a different approach or an additional application to volumes of revolution. Test your understanding. Have a go at the following question, which is determine the volume of the solid formed given Gx is 3x, Fx is 3/4 x squared between x equals 0 and x equals 4 about the x-axis. I've got an answer there for you to check your work.